All right, I'm going to talk through all the solutions for the Algebra 2 final review. So the first one has two solutions. So vertex and the y-intercept do a nice job of describing the height of the golf ball. Number 2 here, they want us to compare the domain and range. So the one on the left, you can tell the graph, it starts at -2, so that's why this is a good domain from -2 and everything bigger than that, so x is greater than or equal to -2. And then you can tell the range starts right at 0 and then it goes up, so that's the reason for that range. And then this one on the right, it doesn't have any big transformations, left and right or up and down, so it's going to be the same as normal. It's just x is greater than or equal to 0 for the domain, and the range you can see there as well. The 2 just vertically stretches it, but it doesn't change the domain and range. Okay, this one has two functions. The g of x is the graph on the left. So you can tell, if you look at the scale, you can tell it goes up as high as 8. So that's the highest maximum value. It's the y-coordinate. And then the other one has this function, and you want to be really familiar with the structure of a quadratic equation. And so the vertex is the hk, so it's the 1 and then the 4. And so that tells us that 4 is the highest that one gets. And we know that's the highest that it gets because it's a parabola that opens downward because of the negative sign. And the highest that it gets is whatever the y-coordinate is of the vertex. So that's 1, 4. So clearly the g of x1 here has that larger maximum value. Similar question for this one. It tells us that this function f has a y value, or the maximum value of 8. So then we're just looking to see, which one has a bigger y value. And so from the structure, again, you can tell that we're really focused on if we're thinking of h comma k for the vertex, we're really focused on the k because that's going to determine, how high this thing goes. So 10 and 12 are, of course, bigger than 8, so we picked D and E. This one is looking for which one has at least one of the two zeros that the graph has, and we can tell the graph has the -3 and 1. So then we just factor each of these if they're not already factored, and that's the reason for the ones chosen. And then you can use your calculator on D, or if you really wanted to, you could multiply it out. So you could do x plus 3 squared, which is x plus 3 times x plus 3, and then minus 1, x squared plus 6x plus 9 minus 1, x squared plus 6x plus 8, and then it factors, and it gives you those zeros. So it would factor as x plus 4 and x plus 2, and then you can tell it's not the one we're looking for. Okay, this one has two functions again to compare. So the g of x1 is probably a nice idea if you just plug it into the calculator. It looks like this one here. And then the f of x is given, and so then we just look for, whichever ones, have the right thing. So b is good because both of the graphs do have a y-axis, that it crosses at 1, just right there, both of them. And then the other thing is that the f of x has a minimum value of 1. You can tell it's the y-coordinate of the vertex. And then the other one has a maximum value of 1, and you can tell that's the y-coordinate of its vertex. All we're looking for here is, the exact same thing as this quadratic equation, but instead of opening upward, it would open downward. And what changes that is just a little negative sign in front of the 4 there. So that's why D is a good answer. How should we change it? If we go from this function to this function, we can tell that they have subtracted 5, to go from the -7 to the -12. So we know that inside the parentheses like that, it's sort of the opposite of what we might think. So we have to move 5 units to the right, to make that x minus 12. All right, we've done a lot of these where we have a little number that's on the outside. This would be like on the outside of the parentheses, if you will. So the 2 is going to vertically stretch it, and the negative sign is going to reflect it about the x-axis. This one is also inside the parentheses. So, how does g to the t minus 5, if you just kind of think of that, a minus 5 inside the parentheses, we know that that shifts the graph 5 units to the right. So that's why C is a nice choice. Okay, if we go from this function, which is the parent function, to this function here, we can tell that the 2 is going to vertically stretch it, so it'd be that one. This 2 underneath the parentheses there would shift it 2 to the right, and then this negative 2 would go 2 units down. Okay, we're going from this function to this function, so we can tell that this would shift the graph 2 units to the left, so it'd be that one. And then the 3 right there would shift it 3 units up. Okay. To go from F to G, it looks like the graph has been shifted 1 unit to the left, and we know that when we go 1 unit to the left, that would actually be adding 1. So I'm not sure how I didn't get my plus 1 there, but this is actually a plus. A would be plus 1 in that spot. So yeah, we just put, that'd be a 1 right there. And then the B, they didn't ask for the B, but if you had to put a B there, you would put a -6, okay, because it shifted down 6 units. But remember, inside the parentheses, it's kind of the opposite of what you might think. We're going left, so you have to add 1 instead of subtracting 1. I think the first solution said -1. Okay. Okay, same thing on this one. It was a little correction. So it's 4 units to the left, so we have to add 4 when it's in the parentheses like that. So then it would be x plus 9 quantity squared plus 4. So A is a good answer instead of B. Okay, so this one we start off with we have our first term, which is 4, and we can tell that it's going up by 5, so we just plug it right into the formula, and then we simplify. So that's the only one that works. And again, you can kind of test it out, right? You can plug in each of the numbers and see if it, plug in n equals 1, and see if that actually gives you 4. Plug in n equals 2 and see if that actually gives you 9, and it does, so it's a valid equation. It's called an explicit formula or explicit rule. All right, first 4 terms, you just plug in a 3, and you can tell from the form here that you're having to multiply by -2 to get the next number. So each time you multiply by -2, and you can see how we get those numbers, the first 4 terms. What's the explicit rule? You just follow the formula. So the first term is 3, the common ratio is -2, and then we raise it to the n minus 1. For paid leave days, that's a good way to start with 4, and then he gets 2 more every year, so that common difference is 2. We're just looking for, which of these formulas actually works. This inequality business is just saying that you would plug in any integer that's 1 or bigger, and it would work well for this rule. So if you plug in a 1 there, this first one, you can tell that would be 2 times 1 plus 2. So that would give you 4, and then you could plug in a 2, and you could see that that would give you 6, and so that's a valid equation, valid formula. And then B, same thing, you just plug in a 1 and see if that would work. If you plug in a 1, that does give you, that would be 0 in that spot, here, so that would still give you 4 as your first term, and then, you can keep plugging in bigger numbers and see that it works. And then this last one also works. It starts with 4, And then you can tell, because this is a recursively defined formula here, that you just add 2 every time to the previous term. So that would work. For this one, we're trying to look to see which ones go together well, that give the same terms. So I was looking kind of at the first term of each one to see if it would work. So this first one, A, doesn't really work because the first term, you can tell from the formula, is 3, and then the common ratio is 9. It's raised to the n minus 1, so 3 would be your first term, and this one says 27, so no good. So start looking just kind of at your first term. For part B, if you plug in a 1 for that one, or answer B, that would be, the first term would turn out to be 12, and that's not the same as 6, and so that one's not good. And then for C and D, they actually work. They give you the same, the same numbers. Okay, pretty much same directions here. We're just trying to see which ones actually work. And again, that inequality business just means that you're allowed to plug in 1 or bigger, and this means you're allowed to plug in 2 or bigger. And that's when the formula starts working. Which value is not a solution? So we would set each of these little factors equal to 0 to figure out the answers, and they're these. And then just look to see which one's not there, so D, yeah. All right, so if you have these zeros, you should be definitely looking for the graph crossing at those spots where it crosses the x-axis. So a couple of them work as far as that goes. A and B for sure. Let's see, any other ones? Then we're also looking at end behavior. So it says that as x approaches, or as g of x approaches infinity, x approaches infinity as well. So you should be looking for a graph that actually goes up. So that's why it goes up on the right-hand side. So this is a pretty good explanation right here. All right, we're looking at zeros. They have these 3, so -5, 0, and 8, just wherever it crosses the x-axis, and that was the only one that had those 3, hitting the x-axis in those spots. Okay, select all polynomials that have a 0 at 4, 0. So look for factors that if you set them equal to 0, they would give you 4 as an answer. So this one, if you set that equal to 0, of course it would give you x equals 4. None of those other ones work, so this one works well, and then this one does work well also. 4 minus x, as you can see the work here. Solve for x, you do get 4. Which one of these, intersects the x-axis? That means that, it has a 0 at 0. So we would look for which ones just have an x. So this one has an x, it has an x twice as a factor. And then this one has an x as a factor. It's a 3x, but it still would work because it would be 3x equals 0, and then we divide by 3. So x equals, it would be 0 over 3 or just 0. And then, of course, the x works. Okay. We're looking for, let's see, which of, just things that are true about this. So the function has 3 zeros. That's true, because you could set the factors equal to 0 to get the answers. And the graph has an x-intercept at 2, 0. That comes from this factor. So those are the 2 things that are correct. Okay, Tom sort of misunderstood how the graph goes here because the zeros you get from setting each of the factors equal to 0, so you get these, and that's exactly where it should cross. So he has it crossing at the opposite, opposite signs. Okay, same, we just set these factors equal to 0, and then get the answers. So D is good. quadratic formula. You have that on your formula sheet. So just remember your a, b, and c are your coefficients that are in front of the terms. So, and then you just plug it into the formula. So this is x equals, and then it's the opposite of b. So that's -1 plus and minus square root b squared. So that's 1 squared minus 4 times a, which is 1, times your c, which is 1. All of that divided by 2 times a. And then you work it out from there. You can see underneath the radical here, we've got 1 minus 4. That gives you -3. We're not really able to take the square root of a negative like that. So we have an imaginary unit, which is the I. And so our final answer is -1 plus and minus I radical 3 over 2. Another quadratic formula. So just plug it in. Got a little cutoff here, when we do the b squared minus 4ac, that should be 296. So 100 minus 296, that's -196 under the radical. And that is a perfect square. So it's 14i, just because of the negative under the radical again. And then this right here, they have 2's in common. So take out all the 2's, and so then that's why it would be 5 plus and minus 7i. Trying to get the x by itself, so you can subtract 12, which is great here, and then take the square root, and when you take the square root, it's 5, plus and minus 5, remember that, and then it has to have the I because it's a negative under the radical again. Okay, this is our, more challenging kind of factoring. Remember the process. We take the first number times the last number, and that gives us 10. And you can make a little, take x. And so you put a 10 at the top, and then 7 here. And we're looking for two numbers that multiply to be 10 and add up to be 7, so 5 and 2. And you rewrite the middle term using those two terms. And we're doing factor by grouping. And remember, you take out whatever they have in common in the first two terms, which is x, and that leaves us with 2x plus 5. And then these don't have anything really great in common, so we just take out a 1, and then that leaves you with 2x plus 5. They both have a 2x plus 5, so we take that out, and then that leaves us with x plus 1, and then you set those equal to 0 to get your two solutions. This one's the easier kind of factoring, so you make a little x, look for two numbers that multiply to be 81 and add up to be -18, so that's why -9 and -9 would work. And then you set them equal to 0 to get your answers, which is the same answer twice. Okay, this is that harder kind of factoring again, so there's your process. So I won't explain the whole process again, but just notice the steps. I reworked that one. All right, this one's just getting the n by itself, solving for n. So subtract 100, you get -81. And then when you take the square root of that, it is a perfect square, but it has to have the I because of the negative under the radical. It's quadratic formula on this one if you want to solve it, because it's not factorable, so you just plug it in and it works out pretty well. We get 16 minus 32 under the radical, so it's a -16, and so that's going to give us that imaginary unit there. And then they all have 2's in there, so we can just divide everything by 2 and get 2 plus and minus I, 2i. Solve for x, so same thing here, subtract 9, you can multiply or divide by -1, and then we get x squared equals -16, we take the square root, plus and minus 4i. Okay, this guy is trying to solve it by factoring, which is great. You just have to move the -45 over to the left by adding it. And then it's a little easier if you divide by 3. So we factor out the 3, and then it becomes the simpler trinomial, where we're looking for two numbers that multiply to be 15 and add up to be -8. So those two numbers work, -5 and -3. This is the powers, the properties of exponents. So remember, when there's a number on the outside of the parentheses, everybody has to get it. So that would be the 2 has to get it, right? So 2 squared and then r, and then you got to multiply the powers. So that would be 2 squared r to the 6th. And so that's why it turns out to be 4r to the 6th. This is the changing the radical to a fractional exponent. So you just have to remember, where the numbers go. So the index, which is that number there, goes on the bottom. So it's just w and then 2 raised to the 2/5. Same thing, remember when there's not a number there as an index, it's always understood to be a 2. So this would be equal to m raised to the 7/2. And then we're just multiplying the powers when it's a power to a power like that. So it's 3 to the 8th, and so then we know that x has to be 8. Okay, so we're looking for all the things that would be the same, so we could change this to a fractional exponent, which would be that one. We can change it to a fractional exponent. This means the same thing because you could multiply those together and that would give you 2/3, or you could just leave it. So they didn't do anything to e. All right. This one, we have to kind of convert it to fractional exponent and then add the exponents. So you can see the work here, 2/1, and then x raised to the 1/2. That's how we change it from a radical to a fractional exponent. And then you need a common denominator. So we change the 2 so that it's 4/2, and then plus 1/2, that gives you 5/2. So that's a good answer. Or you can change it back to a radical. So that's the same thing as the square root of x to the 5th. This is a great calculator problem. So just graph y equals, this function here. And then make sure you know how to utilize your calculator, find a good window, and then just look to see where it crosses the x-axis using the second trace, which is calculating the 0. You'll get that answer, and just round it. This is the easier kind of factoring. We're looking for two numbers that multiply to be 14 and add up to be 9. So 7 and 2 work, and then set them equal to 0 to get your answers. This is the harder kind of factoring. So multiply the first number times the last number, you get -20. So I have it right here. So -20, and then they're supposed to add up to be that middle term, which is a 1. So 5 and -4 works great. So I rewrote that middle term as those two terms, and then did the factor by grouping. This method here is a little bit different. I don't show that. Okay. All right, so completing the square. So first thing you do is you move the constant. This is the constant. You move that over to the other side. So let me see if I can do that one a little bit. So you move that over to the other side. You leave yourself a blank. So that would be 8 plus a blank. And then you add that magic number. So remember, the magic number is half of that middle term right there, and square it. So half of 6 is 3. 3 squared is 9. So 9 is the magic number. Then what that does is that creates a perfect square trinomial. So this thing factors amazing. So it factors as x plus 3 times x plus 3, or x plus 3 quantity squared. and then this side would be 17. So that's why this would be the same thing. All right, same easier question. What's that magic number that you add? So it would be half of this number and square it. So it doesn't matter if it's negative 12 because you're squaring it. So half of 12 is 6, and 6 squared is 36. So 36 is the magic number we would add to both sides. All right, tough to read on this one. It was really tiny. So x to the 0.3, which is 3/10. So then we can change it to a radical, 10th root of x cubed. All right, this one can be a lot of things. So first you can change it to a fractional exponent. So it's 1 over x raised to the 1 over 3. If you wanted to, you could bring this guy up to the top. That would make him extremely unhappy, so he would be negative, and then that would make it this one. Or you could leave it alone, that'd be that one. Or you could be weird and you could make it like this, and you can make it cube root, that would be the same thing. It works because the cube root of 1 is still just 1, so that would be the same. 1 times 1 times 1, so. But that one's awkward and unnecessary, but c'est la vie. Okay. All right, so this one's pretty tough. These are the ones where we multiply by the least common multiple on both sides, multiply all the terms by that, and it magically gets rid of all the fractions. So I multiply by x minus 2, and then I can see that would get rid of that denominator, so then it would just become 2x. And then here you can tell you just have negative 1 times x minus 2, which is this. And then this would cancel out, and it would leave you with 4. And then from there, it looks a lot better. And so we distribute the negative sign and then just solve for x. Unfortunately, we solve for x, and we get x equals 2, but we cannot plug in 2 because it causes the bottom to be 0. So that's not part of the domain. So this would be considered an extraneous solution, so this doesn't have any solution. No solution. Okay, these are the radical equations where we, try to get rid of the radical by squaring or cubing, depending on what the index is. So good idea to square both sides. So then that gives us x minus 4 equals 16, and then we just add 4, so we get x equals 20. And then we always have to check it. I didn't know what this was. This is a check. This is check. So we check it. Make sure you know how to plug the 20 back into the original radical equation and see that it works. And it does. Okay, this one was a mistake. So the only one that is extraneous is the 1, because you do have to solve it first and then check out and see what solutions are not part of the domain. So I have it solved underneath the yellow here. So you can look at the work. I multiplied both sides by x times x minus 1. And hopefully you can just follow all that work there. We get two answers. We get x equals negative 3 and x equals 1. And the one that doesn't work is 1, of course, because that causes the denominator to equal 0. So that's considered the extraneous solution. This one, we want to square both sides just right off the bat. That's what's going to get rid of the radical. So it gives you 1 minus x equals, and then make sure that you multiply this out. So you get exactly the work here, x squared plus 10x plus 25, and then move everything to one side. So, do the opposite over on the left here to get it over to the right. And then everything set equal to 0, and then figure out your double bubble. So this is two numbers that multiply to be 24 and add up to be 11. So 8 and 3 work great. So we get two answers, negative 8 and negative 3, but after checking, the negative 8 doesn't work, and so negative 3 is the only answer. So please Check your answers. Okay, same steps. You square both sides. Get rid of the radical. On this side, make sure you write it out so you get all your terms. Then move everything to the right side, set it equal to 0. Look for two numbers that multiply to be 60 and add up to be 19. That would be 15 and 4. And then again, only one of them works and one of them does not work. So see me if you're not sure how to plug in numbers, please. All right, so if you are solving this one, what are the best first steps? Well, first, you should move that 5 over to the right-hand side, so you'd subtract it, and then you'd square both sides, and then you would finish it, of course. It's hard for me to leave this unfinished, so then you would add 2, so then you get 11, then you can check it. Let me mentally check 11. 11 minus 2, that's 9. Square root of 9, 3. 3 plus 5, check. Yeah, 11 works, but that's not the question. It's the first two steps. All right, same directions. What are the first two steps? Okay, this time you have a 4 in front, so you need to divide by 4 first to isolate the radical. Then you square both sides. So steps right there. I finished this one too, so y equals 1. And it works. You can check it. First two steps again. So square both sides. So that would be 5x minus 7 equals 81. Add the 7, so 5x equals 89. Hard to not finish it. So it'd be 89 over 5, and I don't want to check that one. Well, maybe I do. 89 minus 7, that'd be, that doesn't work. Is that right? Oh, that's not 89. That's not 89. That's 88. Ay, carabamba. That's 88 over 5, and 88 over 5, see, that does work, because then it'd be 88 minus 7, that'd be 81. Okay, so it didn't affect this answer because it's still D, but just the work would be 88 over 5. Cool? All right. Okay, if you want to simplify an expression, please factor. Great advice here. Factor everything first. So once you factor, then I'm making a little video for a final review. So factor everything first, and then you can cancel out some factors. And then same thing on this one. You want to factor it first and then look for some common factors. So this is a difference of two squares. So x plus 3 times x minus 3. And then on the bottom, it's a double bubble. So we're looking for two numbers that multiply to be -6 and add up to be 1. So these are your numbers that work. And then the x plus 3's cancel out. And that leaves you with x minus 3 over x minus 2. Let's see, which ones cannot be used in the following rational expression? So the only way for us to tell is to factor the denominator and see what numbers aren't, that we aren't allowed to plug in, that cause the denominator to equal 0. So it factors like this, and then we can tell, like, hey, -3 and +1 are bad. So those are the two that are excluded. They can't be utilized. Not part of the domain. All right. This one, we just want to solve like the other ones. So we're going to try to figure out the extraneous solutions, but of course we have to solve it first. So we square both sides. So then we're going to do a double bubble here. We're going to multiply this out. So we get x squared minus 2x plus 1. And then on the left, we get x plus 1. And you want to set this equal to 0. So move everything to one side. And then this factors really nicely. So take out an x, and then x minus 3. It's just taking out the GCF. And then we get 0 and 3, and then we were looking for the one that we're that doesn't work, so we got to check it. So if you plug in let's see, if you plug in a 3, then it would be square root, let's see, that would be 3 plus 1 equals 3 minus 1, square root of 4, that equals 2, so 2 equals 2, check. So, so 3 does work. We were looking for the extraneous solution. I lost my brain for a second. So when we plug in a 0, dog's all excited. Okay, plug in a 0, then it would be 0 plus 1 equals 0 minus 1. That would be square root of 1, which is 1 equals negative 1. Does not work. So yeah, make sure you pay attention to what you're looking for. Are you looking for the solution, or are you looking for the extraneous solution? All right, Teresa, she's solving this. So whenever you're solving, this is called a proportion. So this is one fraction equal to another fraction. So just cross multiply. So that's the work that's shown here in red. And when you do that, you should move everything to one side. So this is all moved to the left-hand side, and then you can do a double bubble and factor it. So negative 6 and 1 would be your answers after you set them both equal to 0. So she has it all like perfect. Good job, Teresa. All right. Now, we didn't officially, do this, so they're expecting you to get this wrong, but I'm not, because this is easy. You can do this. So all you're supposed to do is subtract the functions. So f of x minus g of x. So you take this function, you subtract that function. Just make sure that when you subtract it, you know that you're going to be distributing the negative sign. So it's going to, you should probably work this one out and just make sure that you get this answer here. If you're not getting that answer, please check with me, because you should be getting these adding, subtracting, dividing problems correct. Okay? All right, this one, sum, that just means adding together. So that's pretty easy. You're just adding this function with this function, seeing what you get. Combine your like terms, and you get that. This one's also pretty easy, except it has the factoring piece to it. So you just take the f of x, put it over the h of x, and then just try to factor as best you can so that you could cancel out some common factors. So take out a 2 first. When you take out a 2, it would be 2 parentheses x squared minus x minus 6, and then the rest of it factors like this. So it'd be x plus 2 times x minus 3, and then you can see that the x minus 3's cancel out, and then you're just left with, the 2 parentheses x plus 2 on the top, and then x minus 2 on the bottom, and then they just multiplied it back together again a little bit. All right. Same, they just multiplied the functions together. We can do that. We can do a binomial times a binomial, just doing FOIL, first, outer, inner, last. The work here is shown, at least the answers. So 2x squared times negative 3x squared, that's where this negative 6x to the 4th comes from. And then the outside, multiplying these two, that's 2x squared times 2, which would be 4x squared. Then we're working on these ones, so that's negative and a negative, so that's a positive 12x squared. And then we've got the last terms, so negative 4 times a positive 2, which is negative 8. And then we're just going to combine our like terms perfectly like this. All right, so all this is a fancy thing that says we're subtracting. It's just notation for saying that you need to subtract the functions. So just make sure you do it in the right order. So it's the negative x plus 3, and then we're just subtracting the 2x minus 5. So just be careful with your negative signs. We could distribute this, so that would be negative x minus 3, and then we'll distribute this. So that would be negative 2x plus 5. And then we'll just combine our like terms. So negative x, negative 2x, that would make negative 3x. And then negative 3 plus 5, that's where we're getting, wait a second. Oof. That should be negative 3x plus 2. That should be negative 3x plus 2. I'm glad I'm working these out. Okay, so that one is, yeah, let me just make sure here. So subtract minus 2x plus, yep, so that one should be C. Cool. Okay. All right, 69, quadratic formula. So subtract the 26 over to the left, and then you just start plugging it into the quadratic formula. So this one should be good. We've done a couple of those already. All right, number 70, I kind of worked out the quadratic formula again, just a little bit neater, I think, here. So you subtract or add the 20 over to the left, so then you get 40, and then you just plug it all in. Hopefully that all looks good to you. At the end here, you can tell you've got a bunch of 2's in common, so you can take the 2's out. And mathematically, let me just show you once why you're able to, get rid of those 2's like that. The 12 plus 4i, it's kind of like this. You take out a 2, you factor it out, and then it's 6 plus and minus 2i. And then on the bottom, you have a 2 like that. And that's the reason that you're able to cancel those 2's out if they all have a 2, because you're factoring it out of the numerator, and it cancels with the denominator. Cool? All right, same thing, 71, just plug it all into the calculator, plug it all into the quadratic formula. Getting dumb here. And then all these have 2's in common, so you can reduce it. Now you'll notice this little negative sign right here, and then they just, for some reason, threw it way on the outside. It's the same thing, because that little negative sign can be on the numerator or it could be in the denominator spot, so don't be bothered by that. And I think this might be the last one. So we're just solving for n, so subtract the 18, and then divide by 128, and then take the square root of both sides, and then it's kind of this weird, negative 18 over 128. So if you take out a 2 out of each of them, like divide by 2, it'll give you this. And then both the numerator and the denominator are perfect squares. You can plug it into the calculator and do the square root of that if you want. But you get 3/8, and so it's plus and minus 3/8 I because it has the negative under the radical. All right, and I think that's it. So let me just tell you good luck. See me if you have any questions on any of these, okay? Bye.